Hi, Setu. Good evening. Am I audible?
Yeah, also, you're audible. Good evening.
Okay. Okay, so in today's session, we'll start directly with the hands-on session of geodata frames and we using the GeoPandas library. So before moving into that hands-on, first of all, we'll discuss two very important concepts which comes under GeoPandas. Similarly, like in Pandas, we have understood about the series and then we have understood about the data frames. In GeoPandas as well, there are two things. One is called GeoSeries. Another is geo data frames.
Oh,
So first we will understand about what GeoSeries is, and then we'll understand about what geo data frame is. Though we have seen a little bit glimpse of geodata frames earlier as well, means in the same data frames, if you just include one more column of geometry, and that geometry column contains two important aspects of geometry, which is the shape of that geometry and then the coordinate values of that particular geometry. So if you look at a normal data frame, what a normal data frame will look like, it will look like a tabular format, means which where you have rows, where you have columns. Every single column will hold some kind of value and it will have a data type associated to every single column here. If I just want to know what is the data type of a name column, it will be a string. For the place, it will be a integer. As a whole, we'll call it as a data frame. Then the moment in the same table, I'll add a new column here, which is a geometry column, and it has the aspect of shape and the coordinates. So I'll call it that particular uh, values or that combination as a whole as a geodata frame here. So we can say that geodata frame is like a full table which have attribute information along with one geometry column that is called as a geodata frame. Then, as we discussed geodata frame, so if I mention about what geoseries is, so geoseries in normal pandas, series was a single list, a column that you had where you had a single information with a single data type. Here, we also can say that it is a single column.
single column or a row?
Single column. Here,
Okay,
it will be a single geoseries will be a single column of geometries.
okay,
So, why I am saying single, it can be a single column of anything, but why specifically I am writing single column of geometries? Because we are talking about geoseries. When we are talking about geoseries, that means we are talking about geometries. So, hence, I will say, and because of related to our use case, means how we'll use the geoseries in future. So, mostly we will be creating geoseries when I have to combine list of geometries together, when I have to create some kind of shape. In point data, we can say that it is only a single latitude, longitude value. So kind of this is not an example of series. Yes, I agree. But this whole column of geometry will contain lists of multiple latitudes and longitudes. So I'll say that this is a column of geometry with a series of in values of the coordinate. So I'll call it as a geoseries, a single column of geometries. And then geodata frame. Geodata frame will like a complete attribute table along with the geometrical column here.
okay. So here in the geometry point, there is a point 77.2. So it's a lat
Yes.
long, correct?
Yes, these are the
Okay,
latitudes and longitude
long
values.
longitude. So yesterday we have seen about CRS and another one is projected.
Yes,
Uh,
correct.
so this comes under the projected or
No, this
coordinate.
comes under the WGS. In WGS, word coordinate like geographic coordinate system. Geographic coordinate system, in that all the values of latitudes and longitudes are in degrees, like decimal degrees. Whereas in a UTM coordinate system, it will be converted into a meter. So right now our coordinates are in decimal degrees, like 77 degree and like that. So I will say that this is in WGS coordinate format, right?
Okay.
Hmm. And to decide I'll show you once I'll load some kind of a data. After converting, I'll show you how geometry will change into projection system. Okay. In GeoSeries, specifically, we will be mostly talking about geometries. So GeoSeries, the examples of GeoSeries it can be a list of shapes, and that shapes can be point, can be line, and can be polygon. Because we are talking about only these type of shapes that are available within the vector datasets. So only geometry will be there. Means, let's suppose you have to create some kind of a geoseries. Then how will you really create it, that geoseries? So let's suppose I want to create this poly geoseries. I created a variable. I used GPD dot. There we use dot series to create a series, dot pandas to create a dot data frame for a data frame, dot geodata frame for a geodata frame. For a geoseries, we'll be using dot geoseries. And then in that geoseries, I will pass this polygon. So if I need to create a polygon geometry, so I will pass this polygon variable here. But before that, I need to define the variable in the poly variable here. In this, I need to create a polygon, then I have created this list of all the latitudes and longitudes, and then I'm converting this polygon geometry into a geoseries. Also, we have to define that which coordinate system you want to give attached to this particular geometry type. So I want to give CRS as 4326, which is WGS 84. So I'll just run this. So this will be PolyGS will be a geoseries here. You can say that this is a container of geometries with no other attribute information in this. Uh, we will first import GeoPandas. It is not recognizing polygon because I had to define this geometry and it is not recognizing polygon. So I have to use this library called shapely.geometry. Shapely library in Python will help you make the geometries, because otherwise it will be a normal which is containing tuple with some kind of a value. How Python will know that you are trying to give the coordinate value and trying to create a polygon geometry with the help of these latitudes and longitude values. So for that, I need to import this library called shapely.geometry, and I have imported point and polygon. So if I have to create a point, so I'll use import point. Since right now my only requirement is polygon, so I'm only importing polygon. This is not required right now, but so I'll comment these two for now. So only requirement for now is this GeoPandas and Shapely for polygon. So
This from the shapely dot polygon.
yeah.
From where we are importing it, from which library it is?
So
GeoPandas.
from no, not from GeoPandas. We are importing this from like Shapely is the library. So from Shapely library, I am importing the polygon. So now you can say that why you are
Okay.
using from here
Okay.
and
Yeah.
not using from in this. So for this, the argument is that Shapely, in the Shapely library, it is in Python, there are a lot of libraries, and from that,
Okay.
in order to import the polygon from the Shapely, I need to use this particular syntax.
Oh, okay. So
Yeah.
Shapely is a different kind of
Library.
okay.
Yeah. So Shapely is specifically used for creating geometries in GIS. If you have to create
Mhm.
the geometry in the Python, then the Shapely is the library that we will be using.
Oh, okay.
So Shapely is a BSD licensed Python package for manipulation and analysis of planar geometry object. It is used widely to deploy for open source geometry libraries, means all kinds of geometries we can make using this Shapely library. So it is only about geometry. Shapely geometry classes such as Shapely.point are the central data types in Shapely. Each geometry class extends the Shapely.geometry base class. Means this is the base. You can say every library is what? Every library is kind of a class or a function that is predefined and written in Python. So you can say that it is a Shapely.geometry is the base class, and from that, if you want to fetch specific points or the polygon specific geometry, then we can just directly import it from there. So I will share this documentation as well. So here you can see that I have created this PolyGS GeoSeries here. So now PolyGS looks something like that it is index, zeroth index, and it contains a polygon and then series of values in that particular polygon like this.
Then what is import polygon? Import polygon is a function from the Shapely.
Yeah, from the Shapely, polygon is the function which will help you create the polygon geometry. If I have to create a point, so I'll import point. If I have to create a line string, I'll do line string.
Mhm. So in that case, we are the from should be import, right? Because we are importing the Shapely library. So as like we do before, we used to
Bec-
do import pandas as PD or import geopandas as PD. In that way, we need to type import as Shapely.geometry, correct? So, but here we have
uh,
you choose to from.
No, because here I you can think like GeoPandas is the bigger library and Shapely is the similar in the hierarchy. If you see, there is a hierarchy. In that hierarchy, you can say that GeoPanda and Shapely lie in the same hierarchy. But in order to use the GeoPandas capability, I am not going into the exact function of the GeoPandas. Means I am not importing some specific functionality of the GeoPanda. I am kind of importing the whole library in my workflow in order to work with it, right? So that's why
Mm,
I just imported GeoPandas as a whole. I am not choosing specific function of the GeoPanda library.
mm,
Whereas
mm,
here also I can use import Shapely as sh. There is nothing wrong with that. Means import Shapely as sh. I can write it like this. But why I'm avoiding that thing? Because Shapely library contains lot of functions which are irrelevant to me because I only need Shapely to create a geometry for
mm,
polygon. So that's why I'm choosing that from the Shapely.geometry base class, only
mm,
import the pandas. Don't
mm.
import anything else from that.
Okay.
Yeah. So
Here
that's
also, for the example of polygon, we are importing import polygon. If we are
hmm.
going to use any multi-string line or line, again we have to import line or what we will be
Yes,
doing on that
yes.
case.
Here you can see that there are all the geometry type mentioned. So whatever geometry type you want to create, so you can copy the syntax from here. If I want point, I can use a point. If I want multi-line string, I can use multi-line string. These are the keys for geometry collection of one or more geometry that can be of different types. Means if you want different types of geometry to be created in a geoseries, then we can use geometry collection. So like that here, you can see the example from Shapely import. If I want to create, let's suppose both. So I imported point, comma, line string, then point, pass the latitude, longitude, and it needed a single lat long. So that's why in tuple only. In line string, it will be a list of means there will be two lat longs pair, one for the start, one for the end value. So that's why it is a list of latitudes and longitudes. So similarly, like there are a lot of things available, pickling, and then a lot of more other things are also present in Shapely, not just the geometrical aspect. But for us, relevance is that I need to import directly that function so that I can use that particular function from the Shapely. So that's why syntax is such. Okay.
Yeah.
So from this, we have seen how to create a geo series. In this, one more thing that I wanted to mention that can geo like from this we can also say that geo series is a part of geodata frame. So geodata frame cannot exist without a geoseries, because if I am creating any kind of a geodata frame, anyways it will contain this geometrical aspect as a column to the end of it. How will you access that geometry column? Everywhere in a geodata frame, that geometry column will be a geoseries, and we can access that using gdf.geometry like that. If we wait, I think I have put. Okay, so if we look at more difference in this, so GeoSeries is kind of a 1D structure, and GeoData frame is the example of 2D structure. GeoSeries is the column which used for spatial operation, and specifically all kind of geometrical operations. The GeoSeries column will only be used for that. Then it is like a 2D, and GeoSeries will always be the part of geodata frame, and this is used for full overall spatial analysis, because you will be maybe joining the tables, joining the information from the attribute table, and all those things in that. Okay, so now we'll start with actual data frame creation. They are the few libraries which I want to mention here, which we will be using more often. GeoPandas is the main geospatial library, which will help us to work with tables with geometries like point, line, and polygon, and everything we can do with the GeoPandas related to the geospatial analysis. Then later, it is kind of a extension of the pandas library. As I mentioned, Shapely library, we have seen an example also for the Shapely library. Why we need Shapely library? It will help us handle the geometries, objects, point, line string, and operations like distance, intersect, and the basic geometrical operations as well. We can do this using the Shapely library. There is another library with the help of GeoPandas as well. I have yesterday shown you two functions .crs and to_crs to reproject and to check the coordinate system of a geodata frame. But to handle the coordinate system, there is another library as well available, which is called PyProj. This will help you handle the coordinate transformation if you need to transform the coordinate system of your geodata frames or anything. So this library can also comes handy. Fiona, similar to like GeoPandas, that with the help of GeoPandas, we can manipulate, we can read the spatial data and all those things. Fiona is the specific library which is also available for reading and writing the GIS vector files. GeoPandas is a bigger library because it can help you read and write, and it will also help you do the data manipulation, whatever we can do using the pandas. Whereas with the Fiona, I can only read and write GIS vector files. That's why the use case is limited. Hence, we don't really prefer Fiona, but I've mentioned so that you are aware that this is also available. R-Tree are similar, like Rasterio will discuss, but R-Tree is also a library which help you work with all kinds of spatial operation faster, and it also help you with the spatial indexing. We'll see about the spatial indexing later, and the R-Tree also. But again, Fiona and R-Tree library have very limited use cases. Hence, we don't really use and prefer it for the geospatial operation. We'll be focusing on GeoPandas mostly, and the raster, XArray, and the Rio XArray. So if I have to work with all those things, so firstly we will import, as we have seen, and then from Shapely as well, we will import and do all those things. So once imports are done, so whenever we are creating any kind of a script, we will always make sure that we are not importing here and there. We are importing everything once at the start of our script, whatever you think you will be using for your work. So import should happen in a one go at the start only. Now we will create a basic geodata frame. So let's suppose here, if you see this example, I have a name column, I have a value column. In that, I have some kind of a values A and B. In the value, I have 1 and 2. I'll try to convert this into a geodata frame. To convert this normal values into a geodata frame, I will be using gpd.geodataFrame. In that bracket, first in the dictionary, I'll pass my keys and the values that I need to pass. Second important thing for a geodata frame, which is must, is a geometry column. So then I will be passing my geometry information. In this geometry column, I will pass all, in a list, I will pass all the points that I needed, means the latitudes and the longitudes. This is the point layer I'm creating. So hence point and the single lat long value. If it was line string, so there will be two. If it was polygons, so there will be multiple cases. Then the CRS information is must when you are creating a geodata frame, because without this, your layer don't know which coordinate system it should choose to represent these values on the earth. Without this value, it will not automatically go and lie on the exact place on the earth. So without CRS value codes, there is no meaning of GIS layer. So hence I have passed also CRS is equals to in the code, whatever code you want to pass into this. You can pass WGS, you can pass any other UTM as well. It is not mandatory that you should write it in that format. If you have written in latitudes and longitude, because that is the preferred and the most easiest format, means if let's suppose you want to create some geometry, you will go to the Google Maps, you will search for a latitudes and longitudes. From there, you will not get the values in the UTM format. You will only get the values in the, like I'm clicking on this point, I want to create some kind of a point here at this point. So I'll get the values in lat and long format only. So I will copy paste this and I'll pass this here into this point if I want to create a point there. Then whatever CRS I will define here, accordingly, when it will create a geodata frame, it will change those values as per the format. So let's suppose I used, okay, so we created this geodata frame. Now I have printed the CRS. So yesterday we have checked one function called .crs. So .crs will help you know what is the CRS of this geodata frame. So CRS is 4326 because that is what we set. If we'll print the GDF also, how it looks like. So the So it is now a geodata frame. first column, second column, and the geometry column. Geometry column is like this. Let's change this to something called some UTM projection. If you are not aware about what is the code that I should follow, then you can normally directly do a Google search. You'll get this kind of an image. So here you can see that it has divided the whole India into, and the whole world is also divided into multiple zones, but this is specifically for India. So India is divided into multiple zones, and now you can go that your study area or your layer is lying in which particular area, and then accordingly you can choose the UTM zone, that UTM 42, UTM 43, and UTM 44. And then let's suppose my area is lying in UTM 44. So now I have to get the code for this. So UTM CRS code for UTM 43. So the code is EPSG 32643. So I'll use this code. Then I'll come back here. Instead of WGS, I want to pass this UTM code. I wanted to create my layer in the UTM format. So now the input CRS is 32643 here. So now the CRS is in UTM format only. So now when I'll do some kind of a calculation, I'll get the values in the meters for that, for this particular geodata frame. Later on, the geoseries example we have already seen, but let's suppose we'll create a geoseries and then we'll try to calculate the area for that geoseries. The same polygon example I'll take. We created a variable called poly. We are defining, you can say a rectangle you are trying to define using some latitude, longitudes with the polygon, and this polygon is coming from the Shapely library. And whatever this, your order is matters a lot in while you are defining any geometry. You can see that the uh, wait, this should be 28. So the first lat long and the last lat long should be same because it is a closed shape. So it should start from here and then end at here into this. So now what we will do, we will wrap this particular geometry into a geoseries so that your geopandas can finally operate in it. Your geometry should be in a geoseries format only, then and only there can be any kind of a operation that you can perform in this. After creating a geometry, now I have created this geoseries in 4326. Now I am trying to convert it into a UTM or some kind of a coordinate system so that you can do the calculation. So there is a code called 6933 as well for some UTM. So I'm randomly choosing this code. Once you have converted into a UTM, then and only you can perform the area operation. So in your geoseries, you can directly call this dot area, or if you are using a geodata frame, then and also we can do the area calculation by fetching the geometry, which we'll see. So poly AEA, that was our geoseries. Sorry, the after conversion, the variable that we had, dot area will give me the area. But why I am specifically using ilog 0 here? Any guesses? What are we trying to fetch using ilog 0?
No.
Because geoseries is a list. here, if we see GeoSeries is the list. So the output that we'll get will be in the GeoSeries, in the list format only. So from the list, I need to fetch the geometry in order to perform any operation. So that's why I'm using I log 0. So I log 0 will give me the first value, means the first geometry, that the first index value from that list. So then and only I'll be able to access that particular geometry. And then I am dividing that area by 10 to the power 6. So I'm writing 1e6. Why I am dividing it into this? Because I want to convert it in area into meter square. Then I'll just print this area. So I'll get the area for that particular polygon. So it gave me the area in kilometer square. If So you can see this was in meter and this was in kilometer, like that. In the same, for the same geoseries, for the same geometry, if we want to calculate the centroid, so then dot centroid was a function that we can use. So centroid AEA, I created a variable, the same poly AEA geometry. After that, we got after the conversion, dot centroid will help you get a centroid for that particular area that you have. Then I am converting that centroid that I got back into 4326 and dot ilog 0 again, because the output that you'll be getting will be in the GeoSeries. So that's why I am again doing ilog 0. So I'll now print the centroid. Wait, first let's print this. So here you can see that the centroid values are like this. It is in meter format. That's why you will not be able to get what latitude and longitude are you really talking about. So then that's why we have converted it back to 4326, because it will give me the exact coordinate points. So you can see here that this was in meter and it is now in the correct coordinate format, 73.66 and 28.33. Any confusion in this?
No, no.
Okay. So this was in the projected coordinate system and this was in the WGS coordinate system. While I am printing this particular output here, it is always preferred. Right now you can see that it looks absurd because of the round off and all those things. So I'll try to use the formatted string so that I can get the values in a proper format. So we'll try to print formatted string F quotes. In curly braces, I'll pass the area. So area kilometer square. And then I want it as 2F, means only till 2 decimal places or 1 decimal places. So I'll write it, and then after that I want to write kilometer square. So we wrote that. Then print. This is for the centroid I wanted. So I pass both of them with 3F, means I only want 3 decimal places.
The curly braces for what? Is that denotes dictionary?
No, no, no. In print, in formatted string, when we try to write something, try to print something. So in like in the string, whatever I am writing, it will be formatted in that same format, and whatever you will write inside the curly brackets, so it will know that you are trying to fetch some variable from there. So you will pass all those variable that you need to pass into that in order to print that.
Oh,
Just a minute, there is some syntax problem in this. Okay. So now you can see the difference between these prints and these two prints. So it looks more formatted, right? Area in a proper format with proper decimals, kilometer square, and same goes with centroid. It is in proper tuple format because I have mentioned these brackets here. So it is also printing brackets and then the variable that I'm trying to print. So variable value, comma, and then again the variable value. So that is the difference between the formatted string. Okay. Now we have seen things in bits and pieces. Now we will actually load a real data and then we'll try to apply those functions and see how that data looks like. So I have already shared these shape files and data sets with you all, so you can also practice. For now, when let's suppose you have any kind of a data with you, you will first of all upload it in your drives. In your drives, once you are done, then you will come back, you will mount your drive. The first things, once your drive is here, you will navigate to your data set. So I will navigate to my data. All my data set are in this demo data. So I'll go here. I'll try to find some shapefile that I need to load in this. Okay, so this is the file that I need to load. So I'll copy paste this path from here. I'll click on these three dots in the .shp. In the shapefile, you will get lot of files in that combination. .shp files never comes alone. There will be other files as well, but we need to only copy the path for .shp. But we never keep this file separately. It should always be in the package. These files are must .sh, shx, and prg and all those things. So I'll copy the path of this shp. GPD, because I have imported GeoPandas as GPD, created a variable .read file will help me read the file. And then here in the string, I'll simply pass that path. Then once we are created this variable, loaded the path, loaded the file, GDF dot head is the first function that I'll use in order to get an idea how my data frame looks like. Just give me a minute. Okay, so this is one way to read the file and pass the path. In file handling session, I guess we have read about the base path and all those things. So there is another library that we use, which is called path library. Before using path library, wait. Let's suppose you're creating any random variable and this is the path of the file that maybe you have to use again and again for multiple purposes. So if you directly pass the string of the path into this read file, so you cannot use this again and again for multiple other use cases. So the agenda when you write any kind of a code is to how efficiently you write the code, means to create the variable to remove the repeated tasks. So I'll create a variable called path. I will read that path as the R string here. So I'll use the
Hello,
R before the string, means I'm trying to create a raw string here. Yes.
I'm audible.
Yes, you are audible.
That upper line in centroid,
Yes.
uh, that centroid underscore f, you wrote 0 point. Like there is only 1 point. That's why you wrote 0.
Sorry, here. Yeah, there was only 1 point, and yes, that's why I wrote zero because I wanted to fetch the first geometry from that list. If
Oh,
there were multiple geometries in
okay.
that particular geoseries, so then I would have defined if I wanted to fetch the second, third, fourth, or whatever geometry, whatever index from that list. Okay. Am I clear?
Yeah, got it.
Okay. So here I was saying that how you can efficiently pass the path strings into while you are reading the file. So there is one and very direct way that you are just using GeoPandas and .read file and directly pass the path into this and you can directly read the file. I got the output as well, no issues. But let's suppose maybe for some other task in the same script, you might need to use this path again and again. So then in that case, it is always preferred that you create a variable for that. When we create any variable for a path, we always create that variable using the raw string. Means if I am writing R before the quotes and then I am passing my whole path. So basically I am in this, I am reading my path as a raw string and I am saving it in this particular variable. What this helps you with, this will basically help you that you can directly now pass the variable into this read file. So it will treat that as a raw string and as a path while you're trying to read it. And this will also give you the same output. So, but if you're passing the variable while reading the path, so this will give you a flexibility that you can use this variable again in your whole workflow for doing any kind of thing. So this path is will work in any kind of a data, in any kind of a file. This is not respective to .shp only. Either you are reading .tiff or you are reading GeoJSON, JSON, any kind of a file path, you can read it using the as a raw string and then save it in any kind of a variable here, path, or you can give any sort of name to this. No issues. Okay. In this, there is one more way. So this was the raw string method. And then we'll see using pathlib library. This is kind of, you can say that the modern approach, what people these days use in order whenever they are trying to read any path or fetch any kind of a folder or anything. In this pathlib approach, there is a library that from pathlib we can import the path. Here, this path is a function from the pathlib library, capital PATH, like that. Using this path variable, here you can see I am creating a variable called, I will name it as path X. Here I have to call this path function. What this path function will help you with? This function will help you read all the folders and the file from your directory. The better why we actually use this path library, this will work across any kind of platform. Either you are using Mac, you are using Linux system, or you are using Windows system. This will also help you create a variable so that you can reuse. And the extra functionality, like why you should prefer pathlib over the normal raw string, it is easy for joining the path. What I'm saying means easy to for joining the path means, let's suppose you have created this uh, path till this folder, till track3 folder. I'll remove this for now. Okay, so you have created this base path. Okay, so this basically path X dot exist. It is checking that if this folder is already present or not. If this folder will not be present in your directory, so it will create that folder. Let's suppose track3 was already present. I'll write this. So it was false, but it will. So you can see that now I got this track folder as well here. So if in this way, it will also check that this dot exist will check that if the folder is present or not, and this can give you the output in true and false boolean. And if it will not be present, path x dot mkdir means make the directory. So it will make that folder into your dedicated path here. So whatever folder you wrote here, it will create. Now exist OK is equals to true. This simply means that if this folder already exists, do not create that folder again. So if I rerun this, even if multiple times, it will detect this track folder and it will not recreate that folder. It will only reference to this particular folder. Now the other thing that I was saying, that you can join something or some kind of a file into the same path variable. For that joining, let's suppose we already have this path X and I want to add anything into this. So I'll write this as path file. We'll load the track3 only. Inside the track3, I have Yes. So in the track 3 inside this census I have, so I have created base path till here. Now in this base path, I will add this path and join this path. So I write path X and then backslash, and then I can now directly write this. So this way as well, it will detect that file, and instead of path, this path, if I pass this file path as well here, so it will also read my file. So these are the 2 to 3 methods how you can create your path variable, how you can join different folders, create the directory. Why this directory and this path library will help you? Because when we'll do the automation part, at that time, maybe in between your workflow, you need to create some folder, join some folder, or let's suppose after updating this, I want to save my output into the same folder just by adding a slash and writing the file name. So in that case, I can just directly use this pathx variable and then add a slash and then add the name of the updated file, and then I can do the dot to file so that I can save that particular file into my desired format. So these were the ways how you can read any kind of a file. Once that read is done, now we'll see more functions. So dot head will give me an understanding about the first 5 rows of my data frame. Yes.
Ma'am, copy .shp file
Yes.
path. So we have to copy only dots SHP or depend number what we are
No,
doing like
only .shp file. In that whole set, .shp file is the file that you need to bring it, and it will give you all the data.
and why can I
Sorry?
and why we are copying only SHP like dot SHP. We can also
Hmm.
copy like dot PRJ
No, you cannot copy .prj because .prj will only contain the
project.
projection system information about that file. It will not give you the attribute and the geometry and all other aspects of it. In
That's my question. We are copying dot SHP because
Mhm.
we are working on shape. Like
Yes, because we are working on shape. Also, actually, why there are multiple in a shapefile, as I mentioned, shapefile always comes with these set of files. Actually, shapefile is the main format of ISRI, like environment. In ISRI environment, when you load a shapefile, they need all these files to work with it, like dbf, prjsbn, because there, if you are trying to load a .shp individually, it will not be able to load all the information. And in lot of cases, when you have to upload a .shp file for the reference for creating a layer, they always need a zip file of all these files. But there is no limitation as such in Python. If you have to work with a .shp file, I just need .shp file and I can work with it. But for ISRI formats and for creating any kind of a layer in any other platform, I need to have all the complete whole zip to work with it. All these files are relevant for me right now because .shp will contain the metadata also, like the head, the number of coordinate system, and the information and all those things. .shp detects the coordinate system on the basis of how the geometry is stored. That's how it fetches that what is the CRS information for that. Okay. Okay, so once we have loaded this, we have also imported matplotlib library. So I will use the matplotlib library to show you how this data looks like in a plot. Right now, we are using a static plot. We are not using any kind of interactive map. Just using a normal plot and just plotting all the latitude, longitude value in that axis, nothing else. For creating any kind of a matplotlib plot, we'll discuss this figure later. GDF dot plot in the Panda library, we have a function called plot, which will help you do the plotting of your spatial data. So from GeoPandas, I am using dot plot function to plot my geospatial data. Then AX is equals to AX. Here we are defining in what axis of the plot I have to draw this particular spatial data that I'm getting from the GDF. For that reason, I am using AX is the variable where I have to define my axis. Now this axis is coming from matplotlib. Now I have to define here figure comma axis, that I have to define where I have to put my plot. This plt.subplots is coming from the matplotlib library. This is only defining the space. When I'm saying space means where it should plot. Only the layouting part. It is not dealing with the data inside the plot. For plotting the spatial data inside the plot, I am specifically using GeoPandas library. So you can say that this is a combination of matplotlib library and GeoPandas library. Earlier in the previous sessions, I have made one static bar chart plot that was purely on the basis of Matplotlib library, because Matplotlib library is specifically designed for creating static plots with the tabular data. Hence, here we are dealing with geospatial data. That's why I need to use this dot plot function from GeoPandas so that I can plot my geometries. This 1 comma 1, because right now only one row and one column means only one plot I am trying to plot here. If I have to plot, let's suppose you have multiple data sets, means there is one layer, then is another layer, then is third layer and fourth layer. Let's suppose 4 charts needs to be plotted together. So means how many rows and columns will be there? If you think it like that, so in that there will be 2 rows and 2 columns. So if 2 rows and 2 columns I need to plot, so I will write here 2 comma 2. 2 comma 2 like this. So this will define number of rows and number of column I want if I want to plot multiple plots together. If it is only single plot, so 1 comma 1, 1 row and 1 column. That's it. Figure size, this is the size of the layout here. Let's suppose I will write 15 comma 8, and if I run this, so we are not able to see the difference. Wait. So now you can see that it is changing the size. So height and the width. The first one was the height and 20 was the width. Okay, so this is how I can change the figure size of my plot. This was, I am trying to define my whole figure and my axis. Both of the things I have defined here. Then I am only passing my axis here. So it will reference your plot information from this, that how many rows and columns are there and all those things it will plot it from here. Then if I am plotting this, how you have to define the color? Do you want the color the same color? Then I would have directly passed a normal color information here. Fill color I could have passed here. But I want to give the color on the basis of the column. Means if the column on the basis of the state name. So if you look at this data, so I want to give the individual color on the basis of the state name. So I have passed this particular field name st_nm. So all the Gujarat states districts will be given a same color, then Andhra will be different, Jammu Kashmir will be different, Odisha will be different. There will be repetitive cases because the unique thing here is district, not the state. So hence you can see that it has given the color, individual color to all the districts here in this. If you want, you can define your own color as well, which we'll explore later. Line width will define the thickness of the line that you're trying to plot from your data. Edge color, the boundary color. Legend false, right now I don't want any legend, so that is false. If I write true here, so it also gave me the legend for the unique districts data that I have. Later on, we can also manipulate with what exactly do I want in the districts. So this here, we are managing only the data aspect of my plot. Then now we are dealing with the layout aspect of my whole plot. So in my whole layout, what is the title you want for your axis? Means AX is any variable. I can write any other variable as well here. It's not mandatory that it needs to be AX only. I can write axis also, and then in that case I just need to pass the axis here and then pass the axis here and then here. That's it. That's how here it is mandatory. The key is AX only for defining the axis and the layout and all those things. Then dot set title will help you define the title for the axis. So if I'm hovering over this particular function, so if I go and read a little bit about it, set a title for the axis, set one of the three variables axis title, the available data position above the axis in the center. So by default, it will always be in the center. But if you want to do it on the left or right, so we can also do that as well. Parameters are also mentioned if you want to modify the title, font size, font weight, font color, alignments, location, and all those things. Center, left, and right by default, it will always be in the center. But if I want to define the title location, so I can use title location as well. Axis off means the grids. So if I do it on, so there will be grid. Plt.show is finally to show it. So now you can see that I got the grids here for the plot. Though these grids are not relevant in terms of GIS data, so that's why will switch it off. But if you want it to be the part of your plot, you can put it like this. So this is how your data is looking like, and now we'll try to explore more into this. Here, if you see that we have district geometries, specifically this data have the geometry for the district. I want to dissolve all the geometries for the district using the state name. Means I want to create this new geodata frame where I have the geometry, single geometry for a single state. Right now in my data, I only have the geometry for the districts. So what I'll do, I'll use the very first function called dot dissolve. Dot dissolve is one of the GeoPandas functions. You can say special operation. I'll use dot dissolve by how you want to dissolve it. I want to dissolve on the basis of you have to pass always a categorical data into this dot dissolve function, like some kind of a group thing. So we have a group using the state name. So I'll pass st name. By st name, I'll do the dissolve as index false. So I am not concerned with the index now. So I'll leave it
Hello.
as false. Yes.
Sorry for disturbing. Uh, I have a question like, is that a simple figure?
Sorry.
Is that simple figure or we are creating like a layout?
Actually, your voice is very low.
Hello.
Yes.
My question is that a simple figure or we are creating like layout? Like,
No, this is us very simple. This is not a layout regard like the QGIS or something. Are you relating with that layout?
yeah.
Yeah, it is not that layout. It is a normal, simple axis plot like bar graph and chart, how we used to plot in the X and Y axis. So this is a simple X and Y axis. And though ultimately lat longs are the representation of the coordinate on the earth, so we can represent the spatial data into a coordinate system. So you can say that on the axis, I'm trying to plot it. That's it.
So here we cannot add like not arrow and scale.
No, not all those things. Not Harrow and all those things. No. Legend and all basic things we can add in this, but not the North Harrow. Scale, I have to check that if it is available in Matplotlib. Wait. Yes, we can put the scale bar using the pip install matplotlib scale bar. That function is available in this. Because but that scale will be on the basis of the metric, so that will not be the same scale that we get in the layout there. Here we can put a scale, but usually we don't use the GIS data plot for this. I am just using matplotlib so that I can show you. We only use matplotlib for uh, the bar graph or the line chart or anything. Then we will be using, for GIS data, we'll be using interactive maps, the Folium library, context tree library, and all those things. Because this will not be, when you will have to plot some relevant, your main task will be that users will be able to interact with your data. Here, there will be no interaction. It will be only a static thing. Okay. It will not ease your layout making process if you will try to do it. It's better that you will do it on QGIS or anything else after you have the data set. You have better control over that.
One more thing. Uh, we are we are creating like plot na, so why just bigger?
Sorry?
We are creating plot na,
Yes.
why it is like bigger?
Can you please type? I'm so sorry, I'm not able to listen you.
Hello.
Yes.
My question is, we are creating plot.
Yes.
So why it give us figure like diagram figure?
This figure?
No, that output that yeah,
This output, why we are getting?
that figure output. We are creating plot now.
Okay, so why we are getting a like a map kind of output in this?
Yeah, that's it.
Because yes, so because I am using gdf.plot means I am plotting geometrical things into a plot, into a coordinate system. How the coordinate system actually works. In coordinate system, if you try to represent all the latitudes, longitudes on the x and y axis, so ultimately they will lie somewhere, all the points will lie somewhere in your coordinate system, right? So just a minute. Yeah. So if you look at this right now, so ultimately these are our long latitudes and longitude, which are in 90-degree and this east and north direction. When we convert it into a projected coordinate system, so it will be in the X and Y format. So in NXY format, if I am passing only the values, let's suppose I want to create a bar chart. So I am passing something on the X-axis as a categorical data. So it will come here as 1 to whatever value you are passing, like 22 let's suppose year is you are plotting on the axis to 2021, 2022, 2023, like that, and you are plotting some kind of a frequency, some numbers you are plotting, so that number will come on the y-axis. So that is a normal plot thing that you are trying to do. So it will come as a bar graph or a bar chart. But here I want to plot the geometrical aspect, means I want to get that whole geometry into the exact position. So what I did, I converted into a projected coordinate system. Then after converting it, I am plotting every single latitude, longitude, converting it into a meter value. So it will lie somewhere into this X and Y plot. After it will lie somewhere into the X and Y plot, since I am using the GeoPandas dot plot function, not just matplotlib. Here, if you see matplotlib, I just used to create that X and Y. That's it. For that only, we use this as subplots. I am not using matplotlib library for creating and passing the data inside that X and Y. For passing the data in that X and Y, I am using GeoPandas library. GeoPandas dot plot function is very well versed with plotting your exact geometries onto the X and Y coordinates. So that is why it is giving you this layout. And that's why I'm mentioning it will give you a scale bar, but it will not be kind of a correct representation that how exactly we get from the scale bar in the QGIS layout, because there you can actually set what is the zoom level and what all those things. Here, there is it is just representing on X and Y. There is no relation to the Earth right now. So in Python, when you are trying to work with it, it is better that when we will be creating the interactive maps, there you can do the plot and take the screenshot, convert it into a PNG, and then put it on your projects or anything. And if you want particular correct scale bars on all those things, better to do it on the take this data frame from here, do it in QGIS and create that layout using that scale bar. Okay. Is it clear little bit?
Yeah.
Okay. If you go through this last session and we just go through this, so I guess you will get an understanding why we are getting that map as an image into that plot there. Okay, so I was saying about this dot dissolve function. In this dot dissolve function, this is a special operation. I need a single individual geometry for every single state. So I need to pass that on the basis of the state column, do the dissolve of the geometries that are lying inside that particular geometry there. So using the state name, I have created a geometry. So now you can see that I got all the state name, and for every single state name, I have a geometry. Here I got the district column at the end of it, but I haven't gotten all the district. It just added or maybe the first district for every single state that it has got while it was dissolving in my attribute table. So in this attribute table, district information, you cannot take the district into account for doing anything, but it is majorly for state information. Now, if I'll just plot the state name using the same matplotlib, so you can see that I got the geometry for every single state. So I have created this new data from the previous data that I had. So how you can use this specifically for your use cases? Maybe you have some geometry information, and for the district level data, you want a state level boundary as well. Then in the same data set, what we will do, we will try to fetch a specific data, a specific state. We'll try to calculate perform some operation onto that state, and then create that and create a map for that particular state and get an information and all those things. So this is how basically we can deal with this. Now for the same states geodata frame, states become a separate geodata frame. I can use state.head, so it just gave me more information for that particular data here.
Sorry, why it is multi-polygon?
Why this is multi-polygon?
Yeah.
Yeah, so in this data, actually, there's some geometry over there which was multi-polygon. So that's why. In this particular, the data was like that only. So there
Okay.
is no, it is not, I haven't created this data. I just downloaded it from some open source platform. So
Okay. Okay. So the polygon is, what is the difference between the polygon and multi-polygon? Because everything is
looks
one
same.
piece of one, yeah, it
Yeah.
looks like same. If I can understand, if there is a union territory like Pondicherry, there is a some part would be in Andhra Pradesh, some part in Kerala. So in that case, like Pondicherry will be a multi-polygon, but here it looks like it's all under one polygon only. Like Arunachal Pradesh and Assam should be like same, um, like a single polygon, but it looks in the tabular column, it seems like multi-polygon.
Yes. So the multi-polygon and polygon, the difference is simple. in multi-polygon data means while it was dissolving those particular geometries, so what it has done, it has taken 2 or 3 geometries into account and created a separate geometry. So if it is just one exact correct geometrical shape, because maybe there must be some kind of a mistake when they were creating that particular data. So if there is only one connected shape, when I say one connected shape means the start lat long and the end lat long should match together. So it will be a polygon data. But let's suppose you have multiple disconnected parts. It looks like that everything is connected, but in the cases where the multi-polygon is present, means you have 2 to 3 polygons present for that same geometry, but they are so closer to each other that you are not able to recognize it visually. Polygon will represent one continuous area without any kind of a, you can say, any kind of a separation or any kind of a break, whereas multi-polygon is like you might have some separate polygons. Like if we see here there is a very random geometry is present in this area. So maybe when it tried to dissolve all this geometry into a single geometry, might be there was some space between the two lines. So it created some kind of a disconnected geometry here into this.
Oh.
So that is the reason we got mix of multi-polygon and polygon output into this particular state here.
Oh.
And just a minute. If I want to get an idea that how many multi-polygons and polygons are present, so states was my geodata frame dot geometry dot geom type dot value counts. So it will give me that in the state geodata frame, it will fetch the geometry column. Then from there, it will fetch the geometry type, and value count will simply do the count. That's it. So it will give me the output, how many polygons and multi-polygons are present in my data set. And then in this, one more thing. We will try to explode and convert those multi-polygons into different polygons, and then we'll see how it is affecting our data. We'll try to get more into that. So for that, I'll use a different method, which is dot explode. So you can see that now it has created multiple different smaller polygons for those multi-polygons. Because why in Andaman and Nicobar, if you see here in Andaman and Nicobar, so there might be cases that there were many smaller polygons, and in let's assume this case. So maybe there are smaller island, but they all belong to a single geometry, they must have created a multi-polygon and have created a group of these but all polygons together, so that we can say that all these polygon belongs to that single particular state. So but they are all are disconnected, they are not into a continuous geometry, so hence it will always be a multi-polygon. So if I did explode here, so you can see that I got a separate multiple polygons together, but it will not be a true representation of my data. When I say true representation, let's see, I'll do the plot for this single geom. So right now also, if you see here, this one. So they both were in the data, it was something incorrect. In the data, it is green, it is red, and it is blue. So, but this is not correct because this green geometry must be a part of either this state or either this state. Because, and if I compare with the previous plot, so yes, this one. This was something which is wrong. There were two geometries, but they both belong to a single state. So those were the reasons why we are getting a multi-polygon instead of that. So that was the some kind of a data geometrical issues in that. Okay. The same area calculation we'll try to do in this whole geodata frame, and then after that we'll finish this session. So for doing the area calculation, I need to convert it into some kind of a UTM code. 6933 is the special code that is called as a equal area coordinate system. So mostly for area calculation, we prefer 6933, but this can change accordingly to with respect to your study areas. So this is not like a fixed code that every time you should use only this one. So let's suppose we had the state data frame. I have converted into a different, I need to do the reprojection. So I'll use dot to underscore CRS. I have converted, saved it, and then I need to do some modification. I need to add a column, and then there I need to perform that area calculation. So in a geodata frame, when I have to add any kind of column, I'll pick that geodata frame. In the brackets, I'll name that new column. So it is like creating a variable or creating a new column. Then whatever operation you need to perform on that particular column, we'll write it here that in this variable, I need to fetch the geometry first, state AEA data frame, fetch the geometry column, then do the area calculation, divide by 10 to power 6 so that I can have it in the area kilometer part. So I will do the area calculation. So now if I print the states AEA.head, so you can see that I got state area kilometer. In the same, I have to add a centroid column. So same states AEA.geometry.centroid. So I'll run this. And then here after calculating the centroid, we have discussed I need to convert it back to 4326 so that it is in the correct format for the representation in the latitude and longitude. Let's suppose I am printing this. So right now my centroids look something like this, point random like in meters only. But I need them in latitudes, longitudes. So I am using this and converting it into a 4326. So now I have my centroid value as 92.96 and 11.19. Now we have also seen yesterday for the sorting and all those things before that. So let's suppose you want to do a sorting on the basis of state name, because right now they are already sorted, but let's suppose we will choose what? Let's choose district column, not the state name. Reset.index will simply reset your index again after reordering that value. And in that new data frame, what all things you want. Do you want a complete data frame? So you will simply write that complete data frame. But if you don't want that complete data frame, you want some specific columns from the previous data frame, I can fetch that like by passing those column names to create a new data frame. Okay, so if I'm passing some column into the sort values, I need to also have that in my output data frame. So then if I'll print, so it has now sorted on the basis of district. And I only got these 3 columns that I wrote here. If I need to sort it on the basis of state name, so I'll just pass state name, whatever column you need to choose for the sorting, you can choose. Now I got it on the basis of the state name here. Now you can see that there is a plot. Here we are plotting 2 layers together. You can see that for all these polygons, I have a single point of centroid because there was a single geometry for all these multi polygons that I have because they all belong, these all polygons belong to a single state. Same goes with here. Okay. Now, here the example of why we are plotting 2 layers together. So earlier we only wrote states dot plot or GDF dot plot. So only the single layer. Same thing, everything else will be same inside. I need to plot another layer on top of that. So in the order that you will write, it will plot in the same order. So if I'm writing state dot plot first, so it will first plot state, then later I'm plotting centroid, so it is plotting centroid. In the state, I haven't chosen any of the column for the plotting specifically because I wanted the whole and the real geometry of my state geodata frame was polygon. So I have to plot it exactly like that, the same geometry of the polygon. So that's why I haven't defined any specific column to choose for the plot. Inside the plot, if I write any column, so that is used for color, not for the geometry aspect. But here before dot plot, you can see that from the states data frame, I'm choosing centroid column. Means from the state, I don't want you to fetch the exact geometry of that geodata frame. I want you to fetch the centroid column for the geometry and then plot that geometry. So I need to plot this centroid column geometry, like this point on top of that. So you can see that from a single layer, I have plotted 2 different data sets as 2 different layers. Every time you use dot plot function, it will be a separate layer it will create out of that. So I have defined a column here. So that means I want to give the unique color on the basis of that column. So I got a unique color on the basis of that column. Then here I have defined a column that is I want you to fetch the geometry from this particular column because whatever data you will define before the plot, it will use that data for the geometry. Here you can say that I haven't specifically wrote states dot geometry column, then how it is automatically fetching because dot plot function is defined like that it can auto fetch the geometry column on its own without you actually defining it. Here I need to define because my geometry is in centroid column, not in the geometry column. Any questions in this?
No.
Okay, so that was done from in this. You can practice on your own, and if there is any questions, we can take that. And tomorrow again, we'll do some more hands-on on some different data sets. So the data sets also I have shared. So a few more things are there, and then we'll start with the special join concept, means all other functions that are available within GeoPandas for special operations in this. Okay.
Yeah.
Okay. Thank you, everybody.
Thank you.